Hi, I'm Deidre Carrillo and I'm a peer leader here at UTEP, and today I'm going to show you two ways of helping you figure out how to do an electron configuration of a specific element. So basically electron configuration is a way, it's like a language. It's basically telling you where your electrons are in a specific atom. Right, so we all know, or hopefully we know, about s orbitals, d orbitals, p orbitals, and f orbitals, and so on and so forth. So we're going to use electron configuration to go ahead and show where all these electrons in a specific element are placed. So if you want to get a grasp of what I'm trying to explain, you can go ahead and look at your module 10, and this is similar to problem 10. And this is the Gen Chem 1305 Spring 2016 workbook. Hopefully you have something of use. So what we're going to do today, or the example, is the electron configuration of sulfur. Yeah, so sulfur we have here, and I'm just going to go ahead and write over here that I have 16 electrons. Right, so there are a few ways that we can do this. There is something that we know of as this graph. It has a particular name, but I'm not really aware of it. But it looks like this, and basically you use these arrows and fill up orbitals as is, following the arrows. So according to I believe it's the Aufbau principle, is that we want to occupy electrons at the lowest energy, right? So our lowest energy orbital is going to be a 1s, and then we're going to go to 2s, 2p, 3d, and so on and so forth. So one thing to point out is that in s orbital, right, so I guess I'll write it, yeah, I'll write it here. So all these s orbitals, the max number of electrons in an s orbital are 2. And then in a p orbital, the max number that can fill into a p subshell, right, is 6 electrons. And then for a d, just think about it a little bit, but we know as 10 electrons, and then the F is 14 electrons. Okay? So, to continue on, right, so we're going to look at sulfur. And we know sulfur has 16 electrons just floating around ready to do chemistry. So, to start filling these electrons, right, we're going to start out on 1s. So, I'm going to write 1s, and from the 16 electrons, 2 of them are going to jump right in. So, from the 16, we have 16, 15, 14 electrons left, right? So these 4 electrons are then going to go into the 2s orbital, and then we can put 2 into there. And then, so that gives us 12, and then from the 2s, it's going to go up to the 2p, and that's a total of 6. So from 12, I get to 6, and then we're going to go on to the 3s, and we only know that we can put 2 into there, so I get 4 left. And then we're going to jump right back up here to the 3p, and that's, so I only have 4 left, and because I can put 6 into a p orbital, all 4 of them happily go in. Alright, so there is a noble gas configuration, but I'll go ahead and explain that as I show you another method. Right, so the next method is by I personally like to use the periodic table because it's always available to me, right? So sulfur is actually right here, yeah? So what I personally do is I basically start at the lowest energy level, right? So at the lowest energy, we know that we have a 1s. So I'm just going to, I guess, reliterate since we already have the electron configuration. So basically, all the electrons that hydrogen has, sulfur is going to have them, right? So you basically just continue on. So you start from the beginning, and in the beginning you have a 1s orbital, right? So in the 1s orbital, you're going to fill up all the way, and those are the 2 electrons. And then you're going to go down to the 2s orbitals, right? And hopefully you've been talking about quantum numbers, so this makes a whole lot of sense, I'm hoping. So then you go onto your 2s orbital, right, and then you fill those up, right? So I'm basically just going around a line to get to where my element is. So then we we start coming into the 2p orbital, right? And as you can see, as sulfur is here, it's going to fill up all of these, and we have 6 electrons, right? And then we're going to continue on to the 3s. So we have the 1, 2, and then we're going to hit our 3p, and then, as you can see, it's 1, 2, 3, 4, so forth. So whatever method works for you, I hope it's useful. As for the noble gas configuration, this is helium, neon, argon, krypton, xenon. So with noble gases, what we want to do is we basically want to condense this. So sometimes it might be a little tedious if you want to find the electron configuration of, let's say, gold, right? You're gonna have to go through all of this. So what we like to do is we like to condense it. So basically, as you can see, right, is that this here basically represents all the electrons that you see in neon. We always use the noble gas that is right before the element, right? Because our sulfur doesn't have the 18 electrons that argon has, but it does have the 10 electrons that neon has. So this, and then so whatever is different from neon and sulfur, we're going to go ahead and add. Yeah. So this is the noble gas configuration. And another thing to keep in mind is that if they want you to use a box diagram for your valence electrons, so we know that in an S we can have a total of 1 orbital. In a P we have a total of 3 orbitals. A D, there's a total of 5 orbitals, and in F there's a total of 7 orbitals. Yeah? Alright, so what we're going to do is we're going to take the valence electrons. So the valence electrons are the ones that are going to do most of your chemistry. Yeah? So our noble gases are inert. They don't want to do chemistry. So wherever you start seeing electrons that are not like a noble gas, those are going to be your valence electrons. Yeah? So our valence electrons here are these. So if you want to see the box diagram for this, we're going to draw a box for the 3s and for the 2p. 2p, right? So we have 4, 5, 6 electrons that are valence. So according to the alpha principle and a bunch of other principles, we're going to go ahead and start filling them. So we start with the 1, 2, and then 3, 4, 5, and 6. Yeah. So those are this is the box diagram. You can go ahead and write that you have neon. And this is the box diagram for sulfur. I hope this is useful to you. Thank you.